Let me show you one more thing, that any non-Hermitian operator can actually be written as a combination, linear combination of two Hermitian operators. Just like any number can be written as a combination of real number and imaginary part. Any number has two parts, so one is real part and other is imaginary part. Similarly, let us write any non-Hermitian operator O as a linear combination of these two Hermitian operators. Let's say that these two are Hermitian operators. I will check that these two are actually Hermitian operators. So let's start with this. O equal to H1 plus IH2, and if I make O dagger, I will get this. Then I add O with the O dagger. One thing I would like to say, that this is construction. By construction, I have written this line. And so by making O and O dagger, summation of O and O dagger, I have arrived at equation A. Now let me check that whether H1 is Hermitian operator, which means I need to prove H1 dagger equal to H1, which I have already shown here, that if I make H1 dagger, then the first O operator becomes O dagger, and the second one, which was already O dagger, becomes simple O, because my equation A is like this. So if I make dagger of the whole thing, this O becomes O dagger, and this O dagger becomes O. 2 is number, so it remains unaffected. So it's if we write O dagger plus O, it's a summation, so we can write O plus O dagger also, which is eventually the H1 operator. So if I make H1 dagger, I will arrive at H1. Now let's subtract O and O dagger. Now if we make a subtraction O and O dagger, I will get this, and I will have O minus O dagger equal to 2I H2. Now H2 equal to O minus O dagger by twice I. This is my equation B. Now I need to prove that H2 dagger equal to H2. Let's prove that. So if it is H2 dagger, then the first O operator, which was, let me show you equation B. So if I make dagger of this, so this will become O dagger, this O dagger becomes O, and this 2I will be minus twice I, because I am making the complex conjugate. So it's O dagger minus O dagger and then dagger of it, which is eventually O only. The dagger will go out, and there is a minus 2I in the denominator, and I can write this also. So this becomes O minus O dagger by twice I, and O minus O dagger by twice I is nothing but H2. So I have also shown that H2 dagger is also equal to H2. So H1 and H2, these two are Hermitian operators. These are made by constructions. So let me show you one more thing, that suppose this O is a non-Hermitian operator, and if we make linear combination of this O and O dagger, I will get an Hermitian operator. For example, if the linear combination of this O and O dagger looks like O plus O dagger and I O minus O dagger, so this is an operator, this is another operator. Let me show you that this and this both are Hermitian operator. And let's write H1 equal to O plus O dagger. If I make H1 dagger, I will get H1 dagger equal to H1. Similarly, if we get H2 equal to, if we have H2 equal to I O minus O dagger, then H2 dagger will be like this. So it's H2 dagger equal to H2. So combination of non-Hermitian operators can also give us Hermitian operators.